Cool. We're going to quickly look at the landscape of AI opportunities through the lens of agents, opportunities, and touching lightly on capabilities, just as a bit of reassurance about the capabilities of today's AI, especially in the lens of language models, which have become synonymous with AI itself. One useful lens for looking at agents is this dichotomy that was set up by Anthropic between agentic loops and agentic workflows. You have these two different types of systems that both rely on LLMs, and LLMs can take actions in an environment and receive feedback from the environment. So in the classical machine learning sense, agents interact with environments by taking action. So as a human, I'm taking action in the environment. For example, I'm sitting on a chair, I'm typing on a keyboard, and then I'm receiving feedback. So I'm receiving like haptic feedback, I'm receiving warmth, I'm receiving all these different things as an agent from the environment. And an LLM does the same thing, except its interactions with the environment are typically through software, and its actions are text. If you send this kind of text, we're going to use this kind of tool. So you're you're giving the LLM a way to take actions in the world. And then it's receiving feedback because you're like, all right, cool, you did this, and then this happened kind of thing. And then either the LLM or the code can stop doing this at any point. But until that task has been completed, this loop will keep running. That's the theory. In practice, a lot of LLMs get confused. They get caught up in a loop. They get stuck in trying to achieve the goal by trying the same things over and over again. They also have a limitation on how much they can remember. So you need to manage what it is that they're thinking about at the times that they're trying to complete whatever the task is, but you get very powerful systems by building agentic loops. In the same article, we also get introduced to this idea of agentic workflows. And agentic workflows are these systems that are non-deterministic, as in we don't know exactly what this trajectory, technically, is going to look like. But with an agentic workflow, we control certain aspects of the trajectory. We don't control everything about it, depending on how you build the workflow. But having this distinction between the two types is useful. And some examples that they give are routing. So if you were to give the input from any chatbot, for example, to a language model, then that language model can classify whatever request is coming in from a user and then determine what it should do next based on the classification that this router is given to it. An example would be if you have a system that generates both text and images, then you might have one that's an LLM call to reply directly to the user, one that handles images, maybe you have a third one that handles video or errors. But in any case, you have this router set up, and you can also have like an aggregation. There is no limit to what you can build with an agentic workflow in terms of the shape of the graph itself. But these resemble loosely business processes in that it's one step and then another, and sometimes with branching within those workflows. And in the classic sense, actually, only the agentic loop is considered a true agent. And an agentic workflow, some people wouldn't even really call these agents. I refer to all of these as agentic systems because at the end of the day, the LLM is still actually making decisions and determining some things about the way that it works. Also, you can embed agentic loops within workflows, which I'll touch on in a bit. I think it's a very underexplored kind of area, and I've seen some like interesting use cases arising from it. So that is the split between an agentic loop and an agentic workflow. The majority of what we're doing is actually just conventional software engineering, especially in an enterprise setting. So I should say that I've been building AI solutions mostly in enterprise. And most of the issues that you're dealing with are just generic code. So when we're thinking about introducing agentic capabilities, so to speak, all we're doing is we're exiting the context of conventional software. And then we're using what we have available to us in existing software as it works today. We're embedding instructions. We're giving the language model, which is represented here by the Shoggoth meme. It comes from the AI safety community. I think it's pretty consistent with how they actually work. They are this kind of alien intelligence that we've trained to be fluent in human language. So we've got this friendly assistant persona that we typically tell this alien intelligence to imitate, so that then the text that it spits out is actually something that we can use in our applications and not just like random things that it's learned from Reddit. So this language model is taking actions. And the way that it's taking actions is that we've told it, hey, here are all the tools that you have access to. And spoiler alert, you kind of want to give it just as few tools as possible. Typically, most of the systems that I work with, if I'm building a workflow, it can even just be one tool. But if it's a loop, then you kind of want to incrementally increase the tools that you're giving to the language model. And then as it predicts what should happen next, it's predicting also which of the actions it should take. So the text that comes back from the language model, typically in the systems that we build, are giving the language model access to these tools and then taking action within the code. And within your code, you should be handling everything from authentication to anonymizing data to auditing and tracking all of the requests that have been made. So everything that typically lives within code still exists. All of the same paradigms still exist. MCP actually works at this level here of, well, in the way that people think of MCP. People think of MCP servers and MCP clients. For example, you have a Stripe MCP, and that would basically be like, hey, you can make a Stripe payment. And then the LLM's like, cool, all right, here, we're going to make a Stripe payment. And then your code is still the one that's like doing a lot of the execution. It's calling out to the Stripe API as normal software would, and then doing it on behalf of the language model. So this way, you're giving the language model access to the world, right? So that's an agentic loop. That's a conventional agent. And further scene setting here is nobody really knows where on this progression full AI automation we really are. First, we have chatbots. So we had the original kind of like ChatGPT, where it wasn't really connecting to anything. It was just producing text. Then we move on to reasoners. Before GPT-5 was released, we had separate models in all of the different AI apps. And some of those models like DeepSeek R1, ChatGPT's O1, Claude with extended thinking, those are reasoning models and they produce text before producing the actual outcome. And then this definition given here comes from OpenAI, but I believe it was leaked via Bloomberg, if I remember correctly. And so after reasoners, OpenAI's roadmap for AI systems has agents as the next step after reasoning. So they're training models to be agents. And the next step after that would be to have innovators and then organizations that are fully autonomous, whether or not you believe it. That is their thinking. It's useful to know because the models themselves are getting more and more agentic, which means that they're being developed in a way where they do run in a loop and they're able to take actions for themselves. So they're very action oriented, these models. So you have agents, they exist in loops. And this is actually the reason for the meme that you may or may not have seen online, but it's essentially this idea that you have agents, in quotes. Wait, it's just a for loop, always has been. But an agent is literally just calling it an LLM over and over again until you've gotten it to achieve the goal that it's set out to achieve. And you can do that either by giving the LLM full reign to just, keep doing what it wants. So we also have these two different use cases that I think are the most prominent within these true agents, so to speak. And those are coding agents and research agents. And it's kind of like research and development. Although I don't know how profitable the research agents that are out today actually are, but I do think that they have some really interesting use cases. But coding agents, we all have potentially heard of Cursor. Cursor has recently reached 500 million in ARR. So Cursor has a coding agent. Claude Code also has a coding agent. OpenAI coding agent. Google has a coding agent. There are coding agents popping up all over the place. And so a good example is Cursor because Cursor's primary model is selling subscriptions for their coding agent, which has access to these actions. You can see the coding agent is effectively giving the language models, and these are the language models that you're already familiar with. So this includes the GPT models, the O3 model, Claude, all of those models, Gemini. These LLMs are being given access to these tools. So there is a bunch that the language models can use for searching and reading. So reading the file, listing the directory. And funnily enough, when I first set up MCP connections with Claude Desktop, I actually gave it access to a file system MCP, which meant that it was able to read files, list directories, edit files, and delete files, which effectively turned it into a coding agent. So you can have a model running in a loop with access to your file system, and that is, in some sense, actually a coding agent. But search-wise, we have a bunch of different tools. grep is another interesting one. giving language models access to things like grep and searching files, and even just like the access to the terminal or the command line to be able to run its own commands on your computer allows it to be able to, especially as an agent, to be able to find anything. Once the language model actually has the tools to do basic kind of search, it doesn't really have a use for something as complicated as taking in embeddings of the data, especially because I think that only really works for a very kind of specific use case. And then we have research agents like deep research, and there are tools that do research, like even Cursor and the other coding agents. They do a form of research, like they'll research against your code base and the internet. So a research agent, for example, like the one that's built into Claude or into OpenAI, so deep research, has access to a search generally, right? So they're able to search the internet. And in this case, you can see the kind of search that it's created. And then it's received 10 results. And then as an intermediate step, it always does some kind of reasoning, some like thinking about the results that it's just seen. So it emulates kind of like the human pattern a little bit. So it does like the tool use or the action, and then it does some thinking, and then there's the action, and then it does some thinking. And commonly, this kind of system is kind of like a React or Codact type system where you have the agent set up so that it does thinking, action in a loop, just like we've seen with the agentic loops below. And so you might have the system run like this, where it's just doing searches and then getting back its results. And then when it thinks it's finished, then it returns control over to the code again. So that's research agents, coding agents. Those are the agentic loops, right? And if we're thinking about agentic workflows, so like I said, you have all these different systems. An example of routing, like I said, would also be, let's say you wanted to generate an image or respond to the user. But most agentic systems actually look like this, or at least like their core component. Or if you're going to start off building an agent, I would suggest thinking about just trying to do something that's as simple as possible. So first you build like the one prompt, and then maybe you build like the second one. The progression of building agent should look incremental. And actually, when you step back, it's mostly linear. It's actually just like this thing and then this thing. So it's kind of like how people describe the work that they do. If you ask somebody how they do a certain task, maybe they go through their emails and then they check some information across the internet. I'm just talking about generic kind of like knowledge worker tasks. Like first I go to my emails and now I check the internet. The equivalent thing that you would do with language models is, instead of a person reading the information that they've just received from the internet and then making decisions about what needs to happen next, you pass that little aspect on to a language model. If you would otherwise need a person to do it, then that's when you have a language model step in. You don't replace something that could be done with code with a language model. You replace something that could be done by a human with a language model. And that's kind of like the essence of thinking about what is a valuable use case as far as language models go. After introducing both loops and workflows, I think it's important to actually point out that agentic systems exist on the spectrum. You actually have like a very spectrum-based way of looking at systems, or at least I do. I took this quote from some report that I found from the Department of Defense in the States in 2012. And it goes like this: cognitively, system autonomy is a continuum from complete human control of all decisions to situations where many functions are delegated to the computer with only high-level supervision and/or oversight from its operator. Meaning that the conclusion that they came to in this report, where they were figuring out the role of autonomy, literally trying to define like what levels of autonomy there are. And they came to the conclusion that it's a continuum, right? Like you have full human control, you have some human control, you have like high level supervision, you have different levels of interaction with an agentic system. So that's some evidence that our suspicions are true. Also within the AI building space, for example, a Hugging Face have an agentic framework. I generally don't like agentic frameworks, but I do quite like a small agent especially conceptually, because it uses like an agentic loop, but it has a code act pattern that it follows, where the LLM is actually allowed to write the actions that it's allowed to take, because it has access to like an environment where it can write its own code, which is interesting. It's still an action that it takes, but is able to create what the outputs of its action are going to be, because it can write any code for any use case. And Hugging Face, have this description of different levels of agency. And it's not really too important, I don't think, like what their descriptions are, because they have, multi-agent and routers and tool calling and all of that as like separate types of agency level things. I don't think that's all that important, but I do think this acknowledgement that there are different levels of agency is super important. And I'm glad that like the rest of the AI building community is behind that. And then one more proof point and also like interesting topic of conversation here, I think, is Andre Karpathy recently showed this slide at Y Combinator Talk, and he was talking about an autonomy slider and how underexplored the UX behind these agentic systems actually is. He was talking about this whole idea of a generation verification loop between human and AI, which I think is also super interesting, and the type of systems that we should all be building, and definitely the type of systems that I build are very like human in the loop oriented. So building for agents and thinking about levels of autonomy. Let's now look at some of the opportunities that we have in AI. So first, to my point about simple kind of loops. Andrew Ng, former head of Google Brain merged with DeepMind to become Google DeepMind. Andrew Ng is also the founder of Coursera, that famously has the Intro to Machine Learning course taught by Andrew Ng himself. And in this talk at the State of AI Agents, where he's speaking to CEO of LangChain, Harrison Chase, here about how him and his team are using LangGraph, you can see here that he's mentioning building like their most complex use cases using LangGraph. And LangGraph as a system where you can build out these agentic workflows just by specifying like what the shape of the graph should be, and then effectively just putting in your prompts and LLM calls like within that graph. So it's quite a visual way, I think, of thinking about how the system works. It's very business process kind of coded. And then he's talking about how simple these linear workflows actually are and how much opportunity there is, because his company, I think through consulting, they build systems for a lot of different companies. And Andrew Ng being who he is, I'm sure he's working with some of the top companies out there. So it's really super interesting. I think that actually the really valuable kind of use cases actually look very simple. And everything that we see from agents is quite simple in terms of the topology. So the shapes of these graphs, even the really powerful kind of like agentic loop it's just a circle, right? Here is another interview clip. And this time we have the authors of that Building Effective Agents paper that I mentioned from Anthropic. So this is Barry Zhang, and he's being asked by Alex, I want to say Albert, from Anthropic, the types of multi-agent systems that they're seeing in production. What do they look like? What kind of approaches are we seeing? And Barry says something very interesting. He says, I feel in production, we haven't really even seen many successful single agent systems. So that kind of confirms like a lot of what people have been suspecting, which is that most of what people are selling as agentic AI actually hasn't been working. And one of the things that makes this conversation so tricky to navigate, if we break down the way that people talk about agents, there are a few different kind of like patterns for explaining agents. My belief is that the classic conventional understanding of an agent is going to be closest to this as far as using language models to create agents goes. So you have a LLM calling code over and over again. So then a multi-agent system in that sense would be these loops being able to communicate with each other. So then you have a language model or system or a series of language models orchestrated to be able to carry out different actions. So this would probably be the most classic understanding of an agent. But I also see a lot of people explaining their multi-agent systems, and they actually look more like this, where every call that you make to a language model, because you've given it a different prompt, different task, different persona, one that is specific to that decomposed subtask within the workflow, people end up calling like these thing agents sometimes. So maybe this is like a classification agent, and maybe this is a respond to user agent, and then this is an image generation agent. And to me, I don't know, it starts to lose like any kind of meaning, especially because you could have like loops embedded within this. You could have like something that responds to a user over and over again before progressing to the next stage, or something that like generates an image and then branches over here, then maybe does some other task afterwards, right? And if that's a multi-agent system, then that would make this an agent. Every call to the LLM is an agent, which to some extent it's a little bit hard to argue against, just because I'm not calling it over and over again. Maybe I call it once and then it just responds and gets it right immediately. Do I stop being an agent because I take one action to deal with a certain objective or situation? Who knows? And then you just have like your vanilla agentic workflows. It's like, are these not agents anymore? Yeah, I don't know. So another clarification I think that Andrew Ng makes, that they're all agentic, right? Like typically I'll call them agentic, but even here I've kind of called it agents just because agents is just shorter. So a couple of use cases that are important to call out. And again, referencing the same article, one of the use cases that they mentioned is actually a customer support agent. And I built one of these for a Fortune Global 500. And they really wanted a system that would allow them to scale to customers across the world. So they're highly international. They have loads of organizations underneath their parent organization. And they need this system to be available 24/7. And they also need it to be able to speak multiple languages. And so you have a way of capturing incidents that need customer support around the clock through of chatbot conversations, and also which requirement that they specified was to have an email conversation actually picked up by the same agentic system. And the output is always to produce a support ticket, which the human support agents will then use to be able to actually fulfill whatever support task needs to be done by a human. So throughout the building of this process, the human support agents were the ones driving the evaluation and the design and the specification for these systems. And you can imagine like this kind of imaginary, this totally fictitious kind of a description here, but this is just to illustrate like how this type of system might be built. And that is always, as with every agentic system that is worth building in this space, is to first identify the actual use case and then to speak as soon as you can to the subject matter experts about what type of task, like what a description of the actual task to be done is. And this can come in the form of a product requirements document. It can come from shadowing users or shadowing experts, and like gathering this information wherever you can. The quicker you can understand what it is that somebody does for a task that they're trying to fulfill, the quicker you can decompose it into an agentic workflow where you first have the main body of this workflow goes from start to end. So it goes through like this, right? So each of these proceed steps. And then every step within this workflow represents something that a human would otherwise have to do. So for some of the workflows that you build, you have this ability to kind of like scale somebody's work by turning the task into a workflow, but you also have these other opportunities that come from systems enabling use cases that previously didn't exist. So in this case, you have a workflow that first classifies the issue, then routes it, assesses whether you have enough information for a support engineer to be able to take care of it, or perhaps the support agent to take care of it, depending on what skills they have or what type of request has come in, which has all been decided here in the classifying, and then sending it to whatever the support desk system is. This can be by API, it can be by email, all of that doesn't really matter. This is all just conventional software. And then all of the software really should be implementing whatever the proper like governance and guardrailing is for the company. All of that is generic software as well. There is nothing new in it. Like it's following OAuth 2, it's following OpenID, it's following SAML, it's following generic authorization frameworks as a way to manage role-based access control. All of these should be sitting behind something that's kind of gated by an SSO system. And then we have these loops that are embedded within. So I've said already, right, like that these are mostly linear workflows, and you can also have embedded kind of like loops. And here we've added some human in the loop steps within the workflow that are totally conditional. So these dash lines are conditional things that mean that the next step can be either this, or in the case of an escalation, for example, somebody, is like, I want to talk to a human now. It's like, cool, send you straight to the desk, right? Like no faffing. And any kind of clarification that's needed, you ask the user for clarification at the stage where you're doing the classification. And then if you're assessing like whether, we have enough information to be able to send to the desk for them to be able to provide all of the support that the user needs, then, and this is all going to be policy driven, right? So you could do all of this without a language model technically. You could just have something that's code driven, but language models allow you to deal with like more fuzzy kind of requests and situations than generic code does. So yeah, that's why you would use language models here, because for classification, you just wanted to read the whole conversation and then be like, what kind of issue is this based on like how our company defines different kinds of issue, like which bucket does it fall under? And then it will proceed based on that basis. Another type of system that I have seen for companies to innovate using AI is converting technical documentation into coding agents. So you might have a task that you need to complete. And I say coding agents, they have access to like edit and modify files. And so if you have any kind of file system where you're managing like a bunch of modules, for example, and it's complex for users to be able to do that, then you can build like an agent over the top of it. This is effectively the same kind of system that we're describing, like Cursor and all of that. And another kind of use case would be a product research agent where you have something that looks more like a kind of composite workflow where you again have these embedded agentic loops, except in this case, the embedded agentic loop is actually just a research agent. There is a system that I have built for a company that, similar to other systems that I built, where internally there have been efforts for like a year, maybe 2 years to build something, and then I'll put it together in like 2 weeks. In this case, I put this one together in 5 days, gathering this information from user about the type of thing that they wanted to research and the market they wanted to enter into, and then like some categories that were taken from the company's website. And then it would do some research against the competitors, create some user personas, simulate out the user journeys that they would go through the considerations of how they would go about evaluating the different competitor products, and then make some decision around what type of ideas to test out, and then create tickets for the project managers, which I guess internally they can then use to evaluate like ways to innovate within the company. So what I find quite interesting about that is it's like a pure R&D kind of play where you're increasing the volume of ideas to evaluate. And it is kind of going back to that slide that I showed from Andre Karpathy about the whole human AI verification loop. You have this ability to generate multiple ideas and then just take a choice from it, which is a lot of how I use actually the chatbots like a ChatGPT. These are just like a few of the different kind of ideas of things to build based on things that I've seen. There are other opportunities I'm kind of interested in. So you have this idea of like ambient agents that run in the background, but the idea is that they're ambient, like ambient light or ambient sound. So they're always like listening and just reacting to events. They can take longer because if you have a chatbot, you kind of expect a response like relatively soon. It's not 100% the case now that you have the research capabilities because you can always get notified about the research results. And if the scope of research is more important than the time. But you can imagine ambient agents running in a dashboard or in your inbox, listening in for specific kind of emails and then responding to them. So yeah, ambient agents is very interesting because it's fulfilling all of the same kind of needs that a business might have, but it expands like the scope of ways to automate different things that could either save a business money or help them make more money. And I think it's definitely worth building out more of these. And the customer support agent, actually, this whole email system, in my mind, is very much an ambient agent system. And so, you're doing a calculation here to figure out whether it's valuable or not. So here you kind of have a opportunity, right? And if you're not saving money, right, if the value sits below this line, and it's a dead zone, right? You don't want, this is the wasteland. Not every opportunity is going to be valuable. And so if there's not a lot of people doing it, or if the task itself just doesn't add, like it doesn't cost much to the business, then it's probably not worth doing. Over here is actually, this is more the jackpot. Like this is the opportunity kind of frontier, right? So this is a jackpot, this is the dead zone. And yeah, there's nothing, these things here, if you're not saving money, if you're not creating value, don't work on it. If it's not helping a bunch of people, don't work on it. If it's helping, let's say it's helping one person to do a lot, right? But then it might just be that, it's cheap to do and a lot of people do it, then you could be here or you create a lot of value. Then you're in kind of like the jackpot area, right? So this is, this is the opportunity calculator, really. Cool. And if in doubt about the capabilities of AI today, I would just point out there is a absolutely fascinating set of things that have happened recently. These same language models that for a decent amount of time, people were saying, oh, they're bad at maths, they can't do maths, which is still kind of true to some extent. There are some maths that they can't do, but they can at the same time still win gold at what is effectively the Olympics of maths. So the Math Olympiad, the International Math Olympiad 2025, just this year. Gemini 2.5 and also the OpenAI model won gold at the International Math Olympiad, which is very very interesting result. A lot of researchers in the space didn't expect that language models would be able to do this, especially not in 2025. So this has been very, very interesting as far as like AI goes, and a big update, I think, to a lot of people about the idea of like just how capable today's AI are. And then another case that I reference constantly is this research from Microsoft, where the AI was able to outperform a panel of human doctors, where you have five physicians discussing a complex medical case. And these are complex medical cases in the New England Journal of Medicine. And the human panel correctly diagnosed 20% of these complex medical cases. And having a system that's able to diagnose with more than four times the accuracy of human doctors is absolutely incredible. There's a lot of follow-up research that needs to be done. There's a lot of work to be able to get these capabilities in. But this is absolutely astounding to me. We have super intelligence in narrow, high-stake domains, but we're waiting for AGI to come. Language models are very, very capable, right? And people are reluctant to deploy AI. Nobody knows how to deploy AI. And I think what this kind of like landscape view for me represents is thinking about agentic systems is a source of opportunity. So having calls out to, and I define agentic systems as anything that uses a language model, because a language model is agentic. It's having an effect in the real world, right? So it's an agentic system. So you're turning software into agentic systems, and the opportunities are to build very, very simple solutions. XCon in 1986, what's called an expert system, which is a type of AI that's like totally rules based, has 2,500 rules, and it saved the company, they claim, $25 million a year. This is not language models, this is way before language models, right? It's an AI system in some sense. And all it did was generate schematics. Just by doing that, it reduced the time from 10 to 15 weeks to 2 to 3 days. And so the types of systems that I think that we should be building are ones that directly address some challenge that large businesses are currently facing. And by doing this, you can dissolve a lot of different problems. Yeah, this is how you turn the problems into solutions. I think it's by embracing the fact that these language models are capable. Agents are both underhyped and overhyped, right? So they're underhyped in the sense that they are capable. They are very capable. People are trying to downplay how capable AI actually is. A lot of them haven't experienced like just how good these systems can work and how reliably they can work and just how much like value they can represent to the economy, but also overhyped in the sense that people are talking about these massively complex systems, talking about like multi-agent systems, and I think it makes sense. Like a lot of my friends actually build in the space, and they build very interesting applications. I just don't think it's the near term focus, at least for me. Like even if AI stop getting more capable today, I think there are a multitude of opportunities to explore, and yeah.